Hi to everyone and welcome to this Dataforth Corporation webinar. Okay, right now I'd like to introduce today's presenters. With us today is Georg Habner. Georg is a sales and marketing manager at Dataforth. He holds an MSEE from the University of Applied Sciences, Munich, Germany, and an MBA from the University of Arizona. Georg joined Dataforth in 2017. Before joining the company, he held product line management, marketing, and business development positions in the US and Germany. He's a longtime member of the Rotary International, a Paul Harris Fellow, and belongs to the Rotary Club of Tucson Sunrise. Now, also joining us today is John Lehman. John's an engineering manager at Dataforth. He has a master's degree in electrical engineering from the University of Arizona in Tucson and is a licensed professional engineer in the state of Arizona. John has been with Dataforth since 1989 and has been involved in the design and manufacture of all Dataforth products, with emphasis on high-performance signal conditioning products. John has written articles on signal conditioning theory and practice, which have been published in the various trade magazines. So, Georg and John, welcome to today's event. And with that, I'm going to pass things along to Georg to get started. So, Georg, go right ahead.
Hello, welcome everybody, and good morning or good afternoon, depending on where you are. Thank you for joining us. We appreciate you spending some of your valuable time with us today. Have you ever wondered how your data acquisition system can be compact and individualized to your specific measurement, monitoring, and control needs? Yet, at the same time, you want the flexibility to expand or modify your system as your needs change. In today's webinar, we will introduce you to multiple examples using the MAQ20 data acquisition system to provide potential solutions for your application. I'm encouraging you, while you hear about these examples, to think outside the box and imagine how the presented case studies could be available to you and your teams when facing measurement and control challenges. My name is Georg Haubner, and I'm the Sales and Marketing Manager for Dataforth. I will be joined today by John Lehman, our Engineering Manager.
Hello and welcome. We are happy to have you here, and we hope this webinar provides valuable information for you and your company.
Before we take a look at the application examples, I would like to introduce you to Dataforth Corporation in case this is the first time you hear about Dataforth. We will then go back in history a little bit and explore why we have data acquisition and control systems today, and I will explain the components of today's systems. At the end of the webinar, you will have the chance to ask questions. If time runs out, don't worry, we will provide answers to your questions even after the webinar is over. So let's get started. In case you have not heard about Dataforth, you are probably wondering, who is Dataforth? What do we make? And who are our customers? Well, let me tell you. Well, Dataforth has been supplying instrument class industrial electronics for almost 35 years now. We are headquartered in Arizona in southwestern USA, and our production facility has been in Tucson since the company was founded. Dataforth manufactures rugged, high-performance data acquisition and control systems, signal conditioning, and data communication products that all play a vital role in maintaining the integrity of industrial automation, data acquisition, and quality assurance systems. Across the globe, our products have a solid reputation in the industry for very high quality and high reliability. And to further strengthen our commitment to quality, we also secure certifications such as UL, CSA, ATEX, and CE. Dataforth products directly connect to most industrial sensors and protect valuable measurement and control equipment from the dangerous and degrading effects of noise, transient power surges, internal ground loops, and other hazards found in industrial environments. We offer over 1,000 different off-the-shelf modules and provide custom designs to provide complete solutions for interfacing, conditioning, and distributing critical industrial signals. Our complete line of fully encapsulated modules provide performance and durability in rugged industrial environments, while our data acquisition systems are designed for a wide variety of applications. Dataforth products support industry applications from A to Z like aerospace, mining, automotive, temperature chamber applications, and even wine production. Many markets and industries have similar needs. For example, many applications measure and control temperature or pressure and flows of different gases or liquids. In engine testing, for example, engineers are looking at a variety of signals which represent the behavior of power and mechanical efficiency, fuel consumption, or exhaust and emissions, and many, many more. Tools and earth-moving equipment used in mining or in agriculture require intensive testing and evaluation to ensure safe operation before they can be released to the market and used by human operators. Performed tests in the development cycle include, but are not limited to, brake testing, stress testing, or materials and joint movement testing. Power generation monitoring and control equipment often requires higher isolation, remote sensing, and communication capabilities. Additionally, power companies are increasingly interested in performing true RMS measurements as the occurrence of short pulse, non-sinusoidal waves in circuits have increased. In some test and measurement environments, high voltage attenuation and isolation is also required to protect the test equipment and personnel. Dataforth products can also be found in the field of oil and gas exploration. Rugged two-wire 4 to 20 milliamp transmitters connect remote field sensors to computers and control rooms to safely send and receive data between points A and B. Low-power communication links are especially useful in hazardous environments. Process monitoring applications such as food production, metal fabrication, or robotic process automation also benefit from high isolation and product durability. Even in the highly sophisticated semiconductor industry, the performance of Dataforth products is recognized and utilized. Semiconductor processes are expensive and failure rates have to be minimized. To meet exacting production tolerances, the monitoring system must be equally precise with features such as high reliability, durability, and longevity. Cold junction compensation is another factor in assuring optimum process performance. While those are all impressive industries and applications, we have only touched on a few, but I believe it gives you an appreciation of how far-reaching the need and desire is for acquiring real-world signals. Now, some of you may be wondering where the need for acquiring and recording data comes from. Well, let's go back in time. Humankind has always been interested in collecting data and information from and about the objects surrounding them. In the very early times, people observed animals and their behaviors to determine best time for hunting. Later, humans started observing and recording the movements of objects in the skies. Then, approximately 100 years ago, voice and music were recorded for replay, and the usefulness of data collection and analysis as a tool sparked the imagination of many. Eventually, engineers developed data recorders which used paper to capture the measurements. Yet, as the need for data collection grew and the complexity of analysis increased from decade to decade, IBM in 1963 created the first system which truly specialized in data acquisition. One example is the IBM 7700 data acquisition system. Since those early days, engineers worldwide have devoted their time and talents to the development of a wide array of data acquisition systems, from simple to sophisticated, from universal to specialized, and everything in between. The demand for more data, more testing, and more analysis has never been greater. Nowadays, many applications call for comprehensive, simultaneously sampling, monitoring, and control of all types of real-world signals, such as but not limited to temperature, frequency, weight, strain, voltages, current, vibrations, and many more. Sometimes the application requires getting those measurements to a local or remote host computer system. Modern data acquisition systems, also called DAC systems, are often network enabled to allow convenient remote access. Host computers and installed software turn those real-world data points then into user-actionable datasets. Well, let's explore in the next few slides the key elements of such a data acquisition system. According to Wikipedia, data acquisition is the process of sampling signals that measure real-world physical conditions and converting the resulting samples into digital numeric values that can be manipulated by a computer. Data acquisition systems typically convert analog waveforms into digital values for processing. The components of data acquisition systems include sensors to convert physical parameters to electrical signals, signal conditioning circuitry to convert sensor signals into a form that can be converted to digital values, and analog to digital converters to convert conditioned sensor signals to digital values. Wikipedia then goes on to talk about software and other items, but you can look that up yourself. You won't need me for that. One other item to pay attention to in the real world is that every signal carries usually some kind of noise. A noisy signal from a sensor is not clean enough to immediately convert it into the digital world. Luckily, there's a function of signal conditioning to minimize this impact of errors caused by wires and the imperfection of the sensors. In some cases, part of the signal conditioning function is also isolating the high voltage circuitry from the low voltage side where the host computer resides. The first link in acquiring real-world signals is converting a sensor to what is called an input module. There are many different types of sensors available to measure temperature, pressure, strain gauges, frequencies, motion, vibration, voltages, or currents, just to remind you about a few. Usually, every one of those sensors has different electrical characteristics, which means dedicated input channels are required to effectively and correctly capture data of interest. Some applications require simple single sensor inputs, while others demand simultaneous acquisition of multiple sensors of either the same type or different type of sensors. In these multi-channel applications, it is very handy if the input module can handle more than one channel. In some applications, channel-to-channel isolation is extremely important, which requires special input modules as well. In some cases, digital signals need to be captured as well. Therefore, many modern DAC systems have digital or discrete input modules. Besides input modules, many of the existing data acquisition systems also offer output channels to support control functions and feedback loops. Those outputs are generally analog process voltages and process currents. Special cases do require digital outputs such as discrete output channels that can switch DC signals and sync currents, or relay output channels that can switch currents and voltages. Those special function output modules come in handy when special requirements call for a cross-point matrix switch or differential multiplexing for precision measurements, or in cases where multiplexer control is needed to allow combinations of switches to be closed or opened. Modern DAC systems combine input and output channels into one module to achieve higher channel density and save space, allowing the customers to create highly compact systems. Many times, those channels have user-configurable default output states, which are set up on power up or module reset. In some cases, the individual channels of an output module can also be configured to perform special functions. If you had only input or output modules, you would not be happy at all because you won't be able to transfer the captured data to a host computer for later in greater analysis. Many of today's data acquisition systems support different communication methods, such as but not limited to USB or Ethernet communication, and support communication protocols such as but not limited to TCP/IP or FTP transfer or Modbus TCP. But without software, your hardware is meaningless. So, in general, everyone who sells data acquisition systems provides some sort of software. However, good data acquisition system manufacturers are designing their system to allow interfacing to a multitude of other software packages. This open architecture, sometimes supported with APIs, such as the Python API, which is more modern, allows the use of already installed and familiar software, whether it is proprietary or off the shelf. Putting all the individual pieces together, here's a quick look at how a modern data acquisition and control system looks like. Let's move on to the next section and talk about applications. All the application examples we are showing here are real-life applications and real-life challenges individuals and their teams have to overcome. We will discuss some of the examples more generic than others to protect sensitive data and the company that implemented the presented solutions. However, like I mentioned at the beginning of this webinar, I encourage you to think outside the box and imagine how the presented examples can serve as stepping stones to finding solutions to your challenges. The first example is a little bit of a hidden gem because the application is housed in a private residence. The homeowner's goal was to create a PID system which maximizes the time each wood log burns and at the same time minimizes any waste, aiming for maximum efficiency. In applications like this one, a PID controller is ideal. As you may know, PID controllers are used in many automatic process control applications. They can regulate flow, temperature, pressure, level, and many other industrial process variables. Without automatic and continuously modulated control, all regulation tasks have to be done manually. The engineer who implemented this PID solution didn't have the time to continually adjust and control his heating system. The homeowner had used PID controllers from several other manufacturers before he discovered the MAQ20. But how and why was the MAQ20 a better choice? Well, let me turn over to John, who will shed some light on this situation.
Thank you, Georg. This application is interesting from several perspectives. The developed solution was optimal for this homeowner application. This system heats a home in the northeast part of the United States where winter temperatures are very low and sustained. A full wood load is placed in the burner, the system turned on, then the user goes away to work. Throughout the day, a consistent and optimum burn runs, and then the system automatically turns off when the set parameters indicating the end of the process have been reached. In comparison to neighboring homes, this home will consume half the amount of wood during a winter season while producing minimal ash and particulate output. When the system was being developed, equipment from several manufacturers was evaluated. The MAQ20 data acquisition with its built-in PID controllers and wide selection of full-function I/O modules fulfilled all the application requirements and provided the best fit for the developer. First off, the developer found the hardware, system configuration process, and Redax-Shape software all intuitive and easy to install and operate. Next, the hardware and software allow simultaneous operation of multiple PID controllers, some sharing the same input. Multiple trend charts can be displayed on the same view page, allowing the user to make controller changes and watch for resultant trends on one screen. While this may seem like a simple and essential feature, many industry-leading standard multi-loop controllers do not offer this. The PID controller settings accessed through the controller faceplate are extensive and readily at hand, including the adjustable auto-tune. These settings can all be made on the fly. The auto-tune algorithms correctly stimulate the system, read the response, and provide the required coefficients for optimum process tune. This application displays features of the MAQ20 that could be interesting in other PID loop applications in terms of utilized features, cost, compact size, ease of implementation, and reliable 24/7 use.
That furnace application is quite impressive. Wow. It has been running for several years now without any issues, as far as we can tell. Well, let's move on to the next example, which takes us to the moon. Almost. Did you know that the manned Apollo missions placed retroreflectors on the moon? Retroreflectors are constructed of reflective prism faces designed to return an incident laser beam back to its point of origin. This technique provides a way to measure the distance between a target and the point of origin. This method is used to determine the distance between the Earth and the Moon. A few years ago, engineers started developing a new lunar laser ranging telescope which aimed to achieve better performance than other telescopes in the past, targeting sub-centimeter range precision and accuracy to improve the results of previously undertaken measurements. A key to improving the operational performance of the telescope included thermal analysis of the telescope's composite structure to eliminate the impact of temperature variations across the telescope tube. Therefore, scientists developed a 1-meter aperture tube to replicate the physical characteristics of the real telescope. This experimental setup was used to measure the impact of ambient temperature on the thermal behavior of the optical telescope.
A total of 64 100 ohm platinum thin film resistance temperature detectors, also called RTDs, were systematically arranged and thermally bonded on the outer surface of the tube. The positioning and labeling of each RTD sensor was important for troubleshooting and operation. The sensors were arranged on the tube in such a way that they were equally spaced and as dense as possible. This was important for determining a representative distribution of thermal variations of the tube structure relative to ambient temperature. Each sensor, using a 30-foot or 10-meter wire across the ground, was connected to one of 14 MAQ20 RTD31 input modules. Despite the low-level signals coming from the sensors, MAQ20 was still able to achieve 0.08% measurement accuracy. Additionally, important factors included lead wire compensation, rejection of noise, and maintaining channel-to-channel isolation to minimize crosstalk in this high channel count application. The MAQ20 COM4 module was used to transfer the collected temperature data to a host computer, which runs data acquisition software called ReadActShape. ReadActShape is a software application developed by Dataforth to support MAQ20 hardware. This software allows users to set up MAQ20 quickly and without the headaches of learning a complicated programming language. In this case, the customer appreciated the availability of ReadActShape because of the simple installation and setup. Since the customer was looking for a data acquisition system with extremely high accuracy performance across a wide temperature range to cover daylight and nighttime operation, as well as seasonal variations, the MAQ20 performance proved to be up to the challenge. Back to you, Georg.
Thank you, John, for giving our viewers and listeners some background about this very interesting scientific application. The next application is also very interesting because it brings to light the increasing challenges many cities are facing, which is deterioration of buildings, roadways, and bridges. In this example, a historic building needed its foundation restored to prevent the building from collapsing. The question the general contractor needed to answer is, how can we restore the building without our restoration efforts causing further damage or even worse, collapsing the building? It was quickly apparent that monitoring the position and movements of statically important columns would give an indication of potential trouble.
However, general contractors usually have other specializations than developing and installing data acquisition systems. Therefore, the contractor, with help from a local engineering firm, developed this plan to install sensors and a data acquisition system for monitoring any movements of the building during construction. The monitoring system they developed is comprised of 28 displacement sensors and 8 force sensors mounted on hydraulic actuators, which are connected to a MAQ20 data acquisition system located near the point of measurement. A networked general-purpose computer runs IPE-Motion data acquisition software with a specialized plugin to interface to MAQ20 hardware. There were several key reasons for selecting this implementation. Number one, the high channel density fits over 24 measurement channels into a limited available space. Number two, 24-bit data conversion provides the measurement accuracy needed. Number three, within the MAQ20 bridge input module, auto zero, shunt calibration, programmable excitation, and the full bridge interface simplify the sensor readings. In addition, the software requirements included the ability to have virtual channels, broad function in graphical user interface, including limits, alarms, color changes with signal levels, sensor zero, and signal calibration. IPE-Motion has all of these as standard features, as well as many more. In summary, the combination of the MAQ20 bridge module and IPE-Motion software provided a powerful, flexible, and feature-rich solution.
Moving from building monitoring to a test cell, in this example, the customer originally had a large footprint of solid-state relays in a 19-inch rack. This existing implementation consumed a large amount of real estate in the rack, and reliability and maintenance were challenging at times. Our customer was looking for a high-density, small footprint, and a flexible data acquisition solution with open architecture that allowed him to interface to their existing proprietary test and measurement software. It was very important for the customer to have the ability to use an open API to access the data acquisition system. John, why don't you share the details about this customer's successful implementation of MAQ20 and how we helped?
Working with this customer was full of positive surprises. When we first introduced the relay output module to their engineering team, it was not yet ready for full production, but they agreed to be part of our beta test site program. The customer had the opportunity to validate the product performance against the specification in the datasheet, and they were surprised to realize that the product exceeded their expectations. Packing 20 single-pole, single-throw latching relays in a package the size of a smartphone was impressive to them. Each relay can switch between 2 amps at 30 volts and 0.4 amps at 150 volts. Each channel has contact state readback to verify the physical output state. Relays can be controlled individually or in blocks and have user-configurable default output states, which are set upon power up, power loss, and module reset to ensure fail-safe operation. Other features include advanced output functions, which are detailed in the hardware user manual, user-defined logic polarity, and fast switching times. Reserve power is stored and used for predictable shutdown to user-defined relay states upon loss of module power. Output to bus isolation is a robust 1500 volts RMS, and each individual channel is protected up to 150 volt RMS continuous overload in case of inadvertent wiring errors. 150 volt RMS channel-to-channel isolation gives the module the ability to control equipment with or without common mode signal grounds or different pieces of equipment with multiple reference potentials. Like all MAQ20 modules, the MAQ20 DO Relay 20 is designed for installation in Class 1 Division 2 hazardous locations and has a high level of immunity to environmental noise commonly present in heavy industrial environments. While the customer was testing the relay module, they were wondering if we had APIs available to speed their software development. At the time of this request, we had just finished the first version of our Python API, designed to be used for rapid connection to the system and creation of graphical user interfaces to the hardware. This really helped the customer with the evaluation and implementation of the new relay module. Ultimately, the module's compact size, high reliability, outstanding performance, and available software support became the determining factors for them in selecting MAQ20 for their application.
Thank you, John. Moving on to the second to last example, let's take a look at those windmills. In this case, we're looking at an application overseas. Our customer is managing a large wind farm located offshore. Those offshore wind farms tend to be more challenging in many aspects than those located on land. Wind turbine control and safe operation are key concerns. Unlike other industries, wind turbines operate without direct supervision. Components are mounted at the top of the tower, where 6 months may go by between regularly scheduled maintenance. In the meantime, rotating components are generating vibration and heat. All of those can cause parts to malfunction and fail. As you can imagine, accessing the individual wind turbines isn't an easy task. For the wind turbines to remain both operable and in safe condition, components must be accurately monitored and assessed while being continuously protected. Therefore, the service provider in this case was looking for ways to remotely connect to each wind turbine from their control room on land. Because of the number of wind turbines needing monitoring and control, a low-cost, compact, rugged, and flexible data acquisition solution was desired. Additionally, the most important parameters was remote connectivity. Those requirements posed an interesting design challenge.
Indeed, this application is unique because wind turbines operate in many different geographical locations, dictating a wide range of environmental conditions. This includes extremes such as 100% humidity, high vibration, and ambient temperatures from -40 to +85 Celsius. A key aspect critical to wind turbine safety is wind turbine control. Without effective control, wind turbines can speed up in high winds, producing much higher yields than their rated power. Overspeed will also result if critical components fail. For example, if the generator overheats or is disconnected and therefore stops the braking action on the rotor's rotation. Wind turbines generate high voltages and currents. Electrical components within a turbine must therefore be able to withstand high surge voltages and be immune to the electrical noise that can radiate from generators and switch networks. In sum, The challenging environments in which wind turbines operate demand reliable and broad-ranging monitoring, control, and protection. Sensors are used to measure as many as 500 parameters in a modern wind turbine. Conditions that can be monitored include, but are not limited to, generator voltage, current, and frequency, shaft rotation speed, vibration in nacelle, rotor blade, and bearings, and hydraulic pressure. Possible temperature measurements include outside air temperature, drive shaft and gearbox bearing temperatures, and generator temperature. Designed for installation in hazardous locations and with a high level of immunity to environmental noise commonly present in heavy industrial environments, the MAQ20 data acquisition and control system has all the necessary features for wind turbine applications.
In this last application example, we will introduce you to some other tools available for building a data acquisition, monitoring, and control system. These tools are independently available from third-party suppliers and in most cases work with a wide variety of data acquisition systems. The trend to move data to the cloud and have that data available on demand is becoming more and more important for many applications. Imagine you are a city water manager. Before you go to bed, you can quickly and easily check the status of your town's water storage tanks to ensure sufficient water capacity is available. If you see an issue, you can just dispatch your crew. Otherwise, there's no need to waste time and resources to drive by to check the on-site meters. MAQ20 is capable of interfacing to a dashboard called Eagle.io, but there are also other dashboards like DAC.io available. Dashboards offer many other advantages such as historical data access, alarms, and are accessible across different platforms such as phones, tablets, or PCs. If you have your own dashboard, Python API makes it easy to connect, in this case MAQ20, to your own system. Since engineers like to play with toys, we thought let's have some fun with a couple real-time demos we put together for you. Both demos can be accessed on the Dataforth webpage. The first demo utilizes a mobile network, a Digicel modem, MAQ20 data acquisition system, and a weather station. As a way to give you the ability to experience and play with a monitoring application, we have taken those items and created an online real-time demo. A browser-based user interface utilizing our Python API connects via mobile network to a MAQ20 unit here in Tucson. The mobile network connection is made possible by a Digicel modem. The MAQ20 data acquisition system is then connected to a locally installed weather station recording basic weather data. Obviously, this is an extremely simple demo. However, it does showcase the principal capabilities of a modern, remotely accessible data acquisition system, and it does work in real time. Here you can see the actual setup and wiring of the demo system in case you're interested in the details. Since this is a pure monitoring application, we would also like to introduce you to a demo which can do both monitor and control a remote MAQ20. So let's take a look at the second example. The second demo allows you to connect from anywhere via a web browser to a MAQ20 and a process simulator. A video stream provides visual feedback to show the changes you made to the system remotely. Using our Python API, we created a user interface on our web page to emulate the process simulator. This user interface allows you to modify frequencies, to change a slider, or play with a motorized potentiometer. And all of this can be done from the comfort of your office or wherever you are. Keep in mind, both of these demos are real-time working systems. You are not accessing a simulation. We hope that these demos spark your imagination for solving some of your data acquisition, monitoring, and control challenges. With that, let's wrap up and let's take a look at some of your questions.
Okay, Georg and John, thanks so much for that great presentation. Okay, our first question goes to John. John, what sets the MAQ20 apart from other data acquisition systems?
The MAQ20 system offers the lowest cost per channel and is very powerful, flexible, and compact. Just one communications module can interface currently up to 25 input and output modules to create a system with as many as 384 analog or 480 digital channels that fits within a standard 19-inch instrumentation rack.
Okay, thanks, John, for that answer. And Georg, this one looks like it's for you. How much does a MAQ20 data acquisition system cost compared to other offerings?
It depends on the overall system configuration. A small system with COM module and one I/O module starts at approximately $900, while competition is at $1,800. More complex systems with more channels, for example, 96 inputs and outputs, cost approximately $2,000 compared to $3,000 or more from competition.
Okay, thanks for that answer. Georg, here's another one for you. Can I access the weather station demo, and is there source code available?
Yes, everyone can access the weather station demo. The source code can be downloaded from the demo page. You will also find a system diagram on the page and form for feedback. Please use it as it helps us to get better.
Okay, thanks for that answer. And it looks like, John, we're back over to you. How many total I/O modules are offered as part of the MAQ20 system?
At this time, the MAQ20 consists of 25 I/O modules, 19 input modules, and 6 output modules. We continue to enhance the capabilities of the existing modules, and more I/O modules are in development.
And thanks for that, John. Here's another one for you. Are the I/O modules hot swappable?
All MAQ20 modules can be connected while the MAQ20 system is in operation. The communication module automatically detects and registers or unregisters new or removed I/O modules.
Okay, Georg, here's another one for you. Where can I learn more about the MAQ20?
The best place to learn more about MAQ20 is our website. Please visit our website and follow the pull-down menus to access datasheets, user manuals, and software. We also have an FAQ section available for you.
Okay, great. Thank you for that. And Georg, staying with you, which software is available for free download and where?
We provide application software, Reader Shape, and IP Motion for a small one-time fee. A free trial is available as well. Software tools such as the Python API, OPC server demonstration, or LabVIEW examples can be downloaded without any charge.
Okay, Georg, one more for you. Do you have local support in Europe?
Yes, we have local support in all major markets. Again, please visit dataforth.com to look for your local contact information.
And John, it looks like we're going to be back to you with this question. Is Dataforth certified ISO 9001 2015?
Yes, Dataforth is ISO 9001 2015 certified. We take quality very serious and are constantly improving our products and operation. We also stay on top of RoHS requirements and seek CE compliant, UL/CUL listing, and ATEX compliance.
And John, staying with you, can I use National Instruments LabVIEW with MAQ20?
Yes, you can use your LabVIEW software and existing projects with MAQ20. We provide a LabVIEW VI example for free download on our website.
Okay, I think we've got time to take one more question, John. This one's going to be for you. Is host software for MAQ20 available in multiple languages?
Reader Shape is currently only available in English. However, IPE Motion has 7 languages to choose from.
Okay, Georg Habner and John Lehman, we're going to have to wrap things up right there. Gentlemen, thanks so much for taking some time to be here with all of us today. And we'd like to say a special thank you to all of our audience members for being part of this webinar event. Take care and have a great rest of your day.